Hello again, everybody. Welcome to part B of our lesson 2.1 on correlation and association. Okay. All right. Now, scatter plots that we're going to be using, we did that in class already. We have two variables, bivariate data. So one will go on the x-axis, one on the y, and each point will represent an x and a y combination. So that x and that y goes with one single case or one person or one element. Okay. So each point represents a single case. That's our first thing with scatter plots. Okay, here we go. Look for overall pattern. Is it increasing as the x increases or decreasing? Okay, is the pattern linear, curved? Is it just a random scatter? We want to talk about the direction and strength of the relationship. And typically for us, we'll be talking about the linear relationship, the correlation. Okay, and we're going to look for any deviations. So deviations would be any outliers, clusters, or gaps we might see in a scatter plot. So it's a visual picture. We can see ones that are way out there that kind of aren't with the group. Okay, and we might note those when describing these distributions. All right, so scatter plots coming up. Okay, scatter plots, when we plot the data, we have what's called the explanatory variable on the x-axis and the response variable on the y-axis. The idea being that the explanatory variable is the one that might cause the response variable. Okay? Study time, test scores. Not necessarily true, but that would possibly be the answer, like, oh, people study more, they get higher test scores. So the response, the test scores would be a response to that explanatory variable. Oh, I studied more, I have more hours in studying. That would explain why I got my higher test score. And the higher test score would be in response to the study hours. That's the idea. Okay, sometimes when we graph things, there is no explanatory response. We're just doing a scatter plot and there's no connection there, or we don't know if there is, then it wouldn't matter which one you put there. Okay? All right, then I have down here that the explanatory possibly causes the response. Okay? People tell me, a lot of my better math students will tell me independent and dependent variable. Okay, the y is normally the independent because you plug in the x and it depends on what the y is. In statistics, got to break that terminology for me in here, it's the explanatory and the response variable. Okay, again, whatever you're doing here, your thinking may possibly explain what's happening there. Okay, in this particular scatter plot here, I have, it looks like a negative, okay, and a pretty strong correlation. I would say that's 0.8 or maybe 0.9. So either very strong or high, moderate correlation, and it would be negative correlation. Okay, so my R, that's the correlation coefficient, would probably be like negative 0.85, negative 0.9, something like that. Okay? All right, I have an example here. The main idea here is what's going to go where? Okay, I've got weight and height. Okay? How tall I am, does that determine how much I weigh? Okay, or does how much I weigh determine how tall I am? If I were to gain a lot of weight, would that make me get taller? No, okay? And these certainly aren't a very great relationship probably, but how tall I am, if I'm really tall, like 6'5", it would be much harder for me to weigh less. I would generally weigh more than someone that is smaller. Okay, so I would say my height, okay, would cause my weight possibly, okay? Very debatable, but of the two, that's my best choice. Okay, notice you have the inches down here. If you need the scale, we'll have a title, okay, and the units of measure are very important here, because if it was feet, it'd be totally different, or meters or centimeters, right? Okay? All right, and then weight would go here. So what I'm suggesting here is that in this particular situation, it's more likely that your height would cause your weight rather than the other way around. So I think that's my explanatory. Typically on the AP exam, they'll put on the left side will be your X, which is nice. They're not trying to trick you there. That would go in list 1. This would go in list 2 here. Okay, and let's go ahead and graph this while I'm here. Okay, and this looked like, I don't know who these people are. I'm just going to put weights of people. Again, other than the numbers, I have to label my axis with these titles as well. Okay, so on my height, I have to go from 60 to 70. I don't need to start at 0 here. I'm just looking at the parts that we're talking about. Okay, so I'm going to start with, let's go by 2s maybe. If I start at 50, I could start at 60, 62, 64, 66, 68, 70, that'll work. It still could be even bigger. But I'll go 62, 64, 66, 68, 70, 72, 74, okay? I really could spread that out more. It might be a better idea. Okay, my weights, they go from 132 to 200, okay? So I could start at 0 here if I want. It's a more true picture of what's happening, but for our correlation, it doesn't really matter, okay? So you don't need to start at 0. That's an important thing here. All right, let's say 132 up to 195 or 200. So if I start at 130, 140, 150, 160, 170, 180, 190, I'm going to say that's close enough, and we'll put our 200 up there. I'll just draw a line there. It's not behaving for me. Okay, I don't need to label everyone. Okay, we were starting at 130, I believe, 140, 150, 60, 170, 180, 190, and that would be 200 up there. And they're in weight in pounds. Okay, and then we're just going to graph. This is one particular person right here. This guy's 62 inches tall, okay, and has a weight of 141 pounds. I'm going to go up here, 140, just above that. All right, next gentleman or woman, whoever this is, 67 inches tall, okay, and 153 pounds. So 67, this is 68, so right in the middle, 67 and 153, like a little bit above there, okay? And now I have 62 back here. I have another person, but they're 132. Okay, that's okay to have two people. This goes back to your algebra, like it's a function or not a function and stuff, okay? But anyways, that's okay to have two people 62 inches with different heights, that's fine. All right, 72, way out here, 72. Okay, and this person is 200. That's at the top above my title, actually. Okay, and then I have my last person that's 70, and they're weighing in at 195, which is right up here by it. Bring that down. Okay, and then we'd find the line of best fit and plot it on there. I can see, I'm just guessing now, I don't know what it is, and we'll work on that together, but for now, this is what I need from you guys, is just to understand the terminology and what it is we're doing. Okay, and these ones up here probably pull it up towards there. And if you remember our discussion in class, that there are residuals for each of these points. These are the actual points, okay? The difference between the predicted value on the line and the actual one, that difference is called a residual. And in this case, it'd be negative. This has a very small positive residual because he's actually higher than we would predict according to our math model. This one is very close to 0, and it would be a negative residual. He's missed the line. Our math equation, if I were to plug in 62, would have given like just 1 or 2 higher pounds than he really is. But he's a little bit below. It'd be a small residual, and it'd be negative. All right? Okay, and then the other thing I talked about in class earlier was that this line is like the average of everything, okay? So all the positive residuals, if you add them up, and the negative residuals, not how many there are, but the quantity of it, if I add all the values together, okay, the line is perfectly matched. They would equal 0. All the plus residuals with all the minus residuals, they'd add together and equal 0. That should make some sense to you. That line's like the average, is right in the middle. That's why it's it's the least squares regression line, okay, which has the smallest residuals possible of any line there, okay? And I believe that's it for the day. So thank you for your attention, and you don't have to take notes with me in class. So take good notes there, and I will see you back in class. Thank you very much. Oh, by the way, look for an assignment in Canvas. See what I have in there for you. Thank you.